For decades, enterprise data pipelines had a single, rigid mandate: move historical facts from operational silos into a centralized analytical warehouse. These systems were engineered strictly to record deterministic state, the what happened of the business, so humans could read it on static dashboards. Many enterprises are now taking probabilistic large language models and plugging them directly into these pre-AI transactional databases. A traditional pipeline depends on predictable requests. When a probabilistic AI agent navigates raw schemas, the mismatch produces schema instability, API cost spikes, and access violations. To maintain stability, we must deconstruct these friction points and transition toward a decoupled open lakehouse. This is a specific, risk-adjusted blueprint for mid-sized enterprises operating heavily on AWS infrastructure, who are under immediate pressure to deploy agentic AI securely. Ignoring this architectural mismatch creates an exponential cost center and an active operational hazard that threatens the integrity of the entire data estate. The first major friction point happens the moment the AI hits the raw physical database. We call this semantic blindness. Large language models understand the syntax of SQL perfectly. What they lack is institutional domain knowledge. They do not know the business intent behind your data. When exposed to a raw schema, an LLM guesses. Encountering shorthand columns like cust ID v2, its join paths hit immediate dead ends. To compensate, engineers dump entire raw schema catalogs directly into the prompt. This triggers context rot, where the model loses track of buried data. Because transformer models incur quadratic compute costs, dumping raw payloads also causes exponential API cost spikes. Forcing rigid, deterministic data structures into a probabilistic model's context window destroys API budgets, and the AI remains semantically blind. Financial inefficiency is only the baseline problem. The stakes escalate into active operational threats when a hallucinating model actually succeeds in submitting a query. Direct access introduces a critical vulnerability classified as OWASP LLM-05, improper output handling. Passing an LLM-generated SQL string directly into a database interpreter allows prompt injections to execute unauthorized queries and extract secure tables. Furthermore, granting Ask Anything corporate chatbots broad, unrestricted search access across uncurated data stores directly violates GDPR mandates, which require personal data processing to have an explicit, legally documented purpose. Even without malicious intent, autonomous problem-solving threatens infrastructure. An agent generates dozens of parallel, multi-step queries in a fraction of a second. This machine-speed burst traffic creates an orchestration explosion. The barrage saturates application load balancers and exhausts compute capacity until the cluster locks up. Without a mediating layer, plugging an LLM directly into your database transforms a simple retrieval tool into an automated DDoS mechanism and a high-risk data exfiltration vector. To stabilize the system, enterprises must definitively sever the direct connection between probabilistic agents and deterministic storage. The solution is an intermediate semantic substrate, the trusted intelligence layer. Here, analytics engineers use version-controlled YAML files to explicitly document metrics and column meanings. Raw schemas are translated into clean business intent. Next, a smart router pushes heavy reasoning to expensive frontier LLMs, while strict text-to-SQL tasks go to efficient small language models. This substrate ensures the AI interacts exclusively with governed business definitions, preventing it from having to navigate raw, uncurated database states. Beneath that semantic layer, the physical storage infrastructure itself must be modernized to support these AI workloads, forcing AWS-heavy enterprises to make a strategic choice. This matrix evaluates commercial managed platforms against decoupled architectures. Commercial platforms offer rapid deployment, but they introduce long-term compute markups and significant risk of vendor lock-in. The optimal path is the decoupled open lakehouse. The foundation of this approach is migrating your raw analytical data directly into Amazon S3, storing it as highly compressed columnar Parquet files. Over those raw files, we introduce Apache Iceberg, an ACID-compliant metadata layer on S3 storage. Iceberg utilizes a delta log, tracking every modification and commit to guarantee strict data consistency. This permanently decouples physical storage from ephemeral compute engines. You can run AWS Athena or DuckDB directly against S3 files, eliminating brittle ETL pipelines. Bypassing commercial monoliths to build a decoupled open lakehouse ensures absolute data sovereignty and neutralizes perpetual vendor compute premiums. We have solved reads, but must address the final vulnerability, securing write access to prevent autonomous agents from escalating credentials and modifying live data. Restricting access via natural language system prompts is an unreliable security measure. Probabilistic models can be jailbroken. Security must be enforced deterministically at the infrastructure level using an open policy agent gate. The OPA replaces broad, static database credentials with short-lived, highly scoped cryptographic tokens. These credentials, often referred to as valet keys, are strictly bound to a specific user, agent, and intent. These tokens enforce workplace comfort zones. Operations are strictly categorized into green for unconstrained reads, yellow for supervised human-in-the-loop writes, and red for completely prohibited automated writes. This creates the fully realized agentic data estate. The AI agent passes through the deterministic security gate, translates its request via the YAML semantic layer and SLM router, and queries the Apache Iceberg Open Lakehouse directly on Amazon S3. Transitioning from human-driven reporting to autonomous agency requires this architectural pivot. Adopting this risk-adjusted blueprint allows enterprises to manage compute costs and maintain deterministic security while deploying true autonomous intelligence.